on the schedule. You know, we have breaks in the schedule if you're not there on time. So I'd like everybody to meet Stephen Grant. And I'm going to use the microphone, right? Excuse me. No, this is fine. This is as good as anything. So I'd like everybody to meet my long-term partner, Stephen Grant. Stephen is a neuroimaging researcher himself who really started off his work in the PET imaging days and is passionate about the problems of drug abuse in this country. And many of the sort of over beerish kind of discussions. We don't have beer when we talk, right? Many of the discussions of that nature really focus on his very sincere passion for trying to deal with this problem nationwide. And Steve is very much of the mind that that disorders of drug abuse are really disorders of the brain, and this is very much a neuroscience research program that he's on with this. I've known Steve since before the NITP existed, but Steve was on the inside at NIH, really helping along with the vision of trying to create an advanced program for neuroimagers, because he recognized the potential impact of this field on trying to understand the brain, and he understood that this was something that was really about health overall, and worked together with other institutes to try and create the trans-institutional funding that the NITP enjoys. He also has been very much an advocate for basically every innovation we've tried to do in this course, and has stood behind us with everything we've done. And I believe that every of the 10 years you've also participated. Sadly, the nature of being on the NIH extramural inside program is that you don't get to leave the office anymore. And so Steve has participated this way via telecommunications each time, but we're very happy to have him back here. And Steve, it's all yours.
Okay, thank you very much, Mark, for that gracious introduction. Okay, I'm going to switch to the share screen so you can see the presentation.
And if I turn the light, never mind, I'll leave the lights off and bring them on again.
Yeah. So, can you see the presentation? Yes? No?
See your slide sorter view.
Okay. Somehow not in the beginning. Okay, can you see the presentation?
We only see the slide sorter view, Steve.
That's interesting. Let me try this again.
Everybody does have the slides on their computer at this point.
Okay. How about now? Oops. So you can see the slides now?
No, we see the slide sorter.
You only see the slide sorter.
Yeah.
Okay. Technology.
You're probably set up for some sort of dual screen mode, and if you could turn on mirroring, that might work.
Yeah. I don't know why it's coming up like that.
Because you have an audience.
Yeah. Still just slide sorter. Okay, so let me do it this way. It's not that big a deal. Can you see the slide?
No, now we see you.
Okay. You can see the slide now?
Yes.
Okay. We'll do it this way and it'll work. So I am a program officer at some tips in terms of forming your applications, and I will touch upon the review process and how funding decisions are made and how review and program interact. So the first thing I want to mention is NIH funds broadly two types of awards, training awards and research awards. How many of you either have or have applied for training awards? Okay, a couple people, half a dozen. And how many of you may have applied or been involved in the preparation of a research award? Okay, a fair more number. Okay, the main difference between a training award and a research award is a training award has a training plan associated with it. But the principles that I'm going to talk about are very much the same in terms of how you need to structure a grant application. So first, let me go through a couple new developments at NIH. So the first is that there has been a sustained effort and policies at NIH to open up science to the public and to the field of investigators. This started with public access of publications. So now all NIH funded research must be available through PubMed Central, which is freely accessible to the public. And this is now something we track as we look at the progress of a grant. We actually track whether applications are being, I think I'm getting an echo. Maybe you can mute the microphone. So we take this very seriously, and we can actually hold up funding if there isn't documentation that the publications are accessible. This now has moved into the issue of data sharing, and you have this debate on big data, and I'm not going to go over this again. The merits of it, you'll go into the merits of big data and data sharing in your debates. But this is a major issue, a major initiative at NIH, and we have an office of big data. It's called Big Data to Knowledge, BD2K, where they are working out the intricacies of infrastructure and data management across the entire range of biomedical sciences that will allow us to use big data approaches to index data sets and to have publicly accessible repositories of data that scientists across the nation and across the world can continue to use. The BRAIN Initiative continues to be a high-profile item, and after now going into 3 years of the BRAIN Initiative, we're going to start transitioning from technology development to the use of these new technologies in research. And therefore, you will be seeing, either through the laboratories you're working on or your own research, requests for proposals or requests for applications for applying these new technologies, these new approaches to human populations, to animal research across the board. And of course, brain imaging is a huge part of this. For NIDA, one of our main concerns is the rising accessibility of cannabis and cannabis-derived products, and in particular, the effects on brain development. And because of that concern, there is the research on there is the research project, the collaborative research on addiction, which is a network of several institutes that are involved in addiction issues, the Alcohol Institute, NIDA, and the Cancer Institute, because of our interest in nicotine, as well as mental health and child development, have jointly supported this project, a multi-site project called ABCD, which stands for Adolescent Brain and Cognitive Development. And the intention is to study 10,000 children over a course of 10 years, and it may even be 15 years, and they will get a comprehensive battery of assessments, and they will get brain imaging sessions every other year. So the intention is to track the family of trajectories of brain development and to see how environmental events, not stressors, but particularly substances of abuse and alcohol, impact the trajectory of brain development and how sustained those changes may be. For you, the important thing, or the critical thing I want to emphasize, is that the data release will be very rapid. So this will be an open data set, and the data will be released within weeks or months of its acquisition. As soon as it's clean, whatever clean the criteria for clean turns out to be, and there'll probably be several levels of release. So release that's gone through basic quality control for movement and artifacts, and then more pre-processed data that may include alignment or normalization to a standard template that would be released at a later time. But the important point is this is going to be a huge data set that exceeds probably any other single set of data, human brain neuroimaging data. And it's going to be an outstanding opportunity to not only exercise the idea of open science and data sharing, but to apply the principles of big data and the type of analytics that you can't do in a single laboratory study. So this is something that many of you in the room may get engaged in, or it may be a data set that beginning students cut their teeth on. So watch for developments of this. Data acquisition is going to start in September. Okay, so what's new soon? This is actually what's new now, or what's newest. The NIH issued a policy in 2015, or actually late 2015, early 2016 this year, called Enhancing Reproducibility Through Rigor and Transparency. And you can pick up the full text of the notice by just Googling NOTOD 15103. And this came about because, as you've all probably read from various sources, there's a crisis in reproducibility. That is, there's a so-called crisis in reproducibility. And this really originated from the fact that work by people who do meta-analysis failed to show overall effects when they combined the results across many studies in the literature, or at the more basic level, one laboratory was not able to reproduce effects seen in another laboratory, or that effects that were seen at one level of analysis, let's say in cell cultures, did not generalize to whole animals, or most damagingly, preclinical research in drug development was not predictive of response in humans. And so this cut across the entire NIH. It's not particular to human research. It goes from cancer research and cell biology all the way up. So NIH issued a policy that said that applications will be now reviewed on using criteria that address the scientific premise of the application, the rigor of the experimental design, consideration of sex and other relevant biological variables, and authentication of key biological and chemical resources. Now, this past spring was the first time that applications were reviewed in study sections at NIH under this new policy. And at least initially, the major emphasis in the review were on the last two. That is, did the study include both sexes and any other relevant biological variables, such as strain differences and so on? Did they mention or include multiple strains, or make sure that they include most male and females? And if they're using biological resources like antibodies or new reagents, cell culture media, a new drug, that there's adequate quality control to make sure, for example, that the antibody, every shipment of antibody has the same titer, or the titer is known, that the reagents are suitably pure, and there's quality control for that. So this is the first stage, is to say, let's make sure that these sources of variability are not going to influence the results, and therefore they will be more reproducible and the studies will be more rigorous. In terms of experimental design, I'll get back to this in a moment, but the major emphasis here is something that has been a major emphasis in the review for a long time, at least at this stage, which is that there's an adequate power analysis for the preliminary data. The scientific premise is a little bit more complicated. You already have to write a background and significance statement, and I'll go through that in a moment. But as we see through this lots of text, and I'm not going to read it to you, this new policy is asking for a more critical review of the literature that you're using to justify your experiments. So rather than making a statement that investigators X, Y, and Z have found that this brain area is activated under these conditions, you're now expected to say X, Y, and Z found this area to be activated, but X used a uncorrected threshold, and investigator Y did not use a good motion correction algorithm, and investigator Z had good procedures, but they found something different, slightly different. So, excuse me. Now I'm going to conduct a study to overcome these limitations and gaps. The problem is, and this may be why review hasn't concentrated on this aspect so much, is there's been no expansion in the page limits. So you're expected to expand the description of the literature, but you're still limited to either 6 or 12 pages for the research proposal. So I don't know how that problem is going to be resolved, but it's something to keep in mind for the future. Okay, I'm going to now go through a series of explanations of what makes a good application and some formal criteria, and explain the formal criteria, and then go and also provide you with some acronyms and tips that may help you in writing better proposals. The first thing, and if you remember nothing out of my whole presentation, is that writing a grant application is not the same as writing a publication for a journal, nor is it reviewed in the same way. And a grant application isn't even a veridical description about how research is actually conducted in the laboratory. It represents an ideal of how the research should be conducted under optimum conditions. And so I use this quote from Albert Whelan, who was head of the satellite program at the Department of Defense, where he makes the point that writing winning proposals is different from building winning hardware. And I would make the same case here that writing an application that will get a fundable score from peer review is not the same as writing a publication that will be accepted from a high impact journal, nor is it the same as the way that the research may end up being conducted. So let's go back to fundamentals. There's the NIH mission statement. Now, for many years, I didn't pay attention to the NIH mission statement because mission statements are usually broad and non-specific. But in this case, the NIH mission statement has become something that I encourage people to include in their applications, because the pendulum keeps swinging at NIH and other agencies between fundamental research and applied research. And for a period of time, you were hearing comments from NIH leadership and NIH Institute directors that we weren't translating basic findings into effective treatments. And therefore, there had to be more emphasis on the translation to effective treatments, what you may have heard as bench to bedside. And then reviewers in study sections took this seriously and started saying, well, this person in their application said this could have implications for the treatment of Alzheimer's or schizophrenia or substance abuse, but they don't say exactly what that treatment will be or how this will be used in treatment. And then the application would get a good score. In order to overcome that misunderstanding by the peer reviewers and overinterpretation of NIH leadership comments, I started encouraging people to include the NIH mission statement to emphasize whether that if you're doing fundamental research, NIH supports fundamental research. If you're doing translational research or applied research, that NIH supports that too. And to quote the mission statement and to be very clear in your application what kind of research you're proposing to do and that this is appropriate for an NIH application. Fundamental knowledge or fundamental basic research is critical to public health because there is the critical assumption, a fundamental assumption, that if we understand the mechanism of a disease, we will have a rational target for intervention, either for prevention or treatment. So this is the value of basic research to NIH. This differs from other agencies, for example, NSF, which their mission is basic research for basic research's sake. So it's important to understand when you're writing your application that it should be tailored to the mission of NIH. Okay, how is your application evaluated? Applications are reviewed by other active researchers in the field who gather together in what is called a study section. And there are, I don't know, tens, maybe 100 different study sections that are specific to certain types of research. So part of the art of writing a good study section, of writing a good application, is tailoring it to the reviewers that serve on the study section where your application will be reviewed. How do you find out what study section your application will be reviewed in? That's where I come in as the program officer, and I'll get to that in a little while. These peer reviewers assess applications and give it a bottom line score that ranges from 10 to 90, 10 being the best, 90 being the worst. And this score reflects the likelihood that the project will have high impact, meaning a sustained, powerful influence on the research field involved. So applications that are incremental, that only, they may be technically perfect, but if they're incremental, just some minor variation of something is already well established, then it's likely to get a poor impact score because the influence on the field may be considered to be small. This language comes directly from the regulations that govern NIH, that they should assess the overall impact. Now, impact scores are reviewers are instructed that the impact scores have qualitative descriptions that correspond to 3 bands. So a high band, a medium band, and a low band. Applications in the high band have high impact, high importance to the field. They're going to move the field forward a great distance. It's going to resolve a controversy or break new ground. And it has trivial or no technical or methodological weaknesses. Those are applications that get scored somewhere between 10 and 30. The medium band may have high impact, but it has technical weaknesses, or it may be technically pristine, but it has moderate impact. And then the low band is low in both of those areas. You want your application to be in the high band. And not only that, you want it to be in the high part of the high band. So fundable applications need to get a score in the 20s in order to be fundable these days. It's a very high bar, but it is, people obviously do get these scores. And if you pay attention to the issues of explaining to the reviewers that what the impact of your study will be, and that explaining the methodology in sufficient approach in sufficient detail and clearly enough that they can see that there are little or no technical flaws, you will end up in that high band. Now, the impact score is broken down to a number of criteria. So the applications are assessed in a formal way on the following criteria: the significance of this application, in other words, how will this advance the field? The innovation of the application, is this something that is just a repetition of what's been done for 30 years with a minor tweak to it? Or is this a new conceptual framework or a new methodology that is breaking new ground? The approach, which is where the details of the methodology are explained. The investigator, which is you, how qualified are you as an investigator, and what's your track record of productivity to conduct the research, and are you in the right research environment? If you're proposing to do an fMRI study, does the institution have a fMRI scanner? Is it dedicated for research? Do you have to drive over to a local hospital? Are you planning on getting a scanner, but it's not there now? That's what goes into environment. Of these criteria, approach is overwhelmingly the criteria that correlates best with the overall impact score. Each of these criteria receives a score from 1 to 9 by each reviewer, each of the 3 primary reviewers. However, the final score is greater than the sum of the parts. There is no mathematical relationship between the final score and your the various criterion scores. So it is feasible and allowable that you could get 1s on every single criterion score and get a 3 or 4 impact score, because as a whole, the reviewers are not as excited about the application, even though each one of these criteria may be outstanding. They may feel that there's something that's not captured in the criteria that leads to weaknesses in the applications. Using feature that people often don't understand when they get their first summary statements. Does somebody have a question in the back? No. Okay, just stretching. All right. So what happens? What is the criterion for how does a study section operate? And what is the culture of review? Now, NIH has a different form of review than other funding federal government agencies. Let's say it has differences than NSF. NIH has two characteristics that are very important. One, there's a firewall between program and review. And again, I'll address this at a later point, but each serves a different function. Review assesses scientific merit. Program establishes goals, long-term and strategic goals or short-term goals, and makes funding decisions. So the study sections do not make funding decisions or even say whether something should be funded. They simply assess the scientific merit. Now, the original mission of study sections was to weed out bad science. This was so long ago that neither Mark nor myself were alive when this was the case, when there was more money than there were investigators. And they wanted to weed out essentially crank science, really, really bad science. And so they established this system of review to identify things that had, where the emphasis was, is this bad science? This culture of skepticism has persisted for generations. It's an interesting social psychology or anthropological question or sociological question. But study sections are very much like a journal club. They're highly skeptical, and just like in journal club, the practice is to pick applications apart and find any flaws that may lead to uninterpretable results or null results. That is, there won't be interpretable results. So there's a dynamic at NIH between wanting to push the cutting edge of the field and advance our scientific knowledge, and the corresponding skepticism that leads to a fear of failure. That what is it about in the application that will lead to the project not working? If you can balance those two aspects, then it's likely that you will get a good score. Unfortunately, this approach often leaves people, or this dynamic often leads people to overemphasize one part or the other. So if you're too conservative in your approach and methodologies and hypotheses, then you'll get poor scores on the innovation criteria. If you're too cutting edge, or you don't have appropriate pilot data, then there's a risk of failure. So how is an application structured? So there's the different criteria, but the application itself, as you well know, is a formal structure that has specific sections. The significant section, which is where you establish the scientific premise for the study, is where you say there is a gap or controversy in our knowledge, and that you're going to resolve this gap or controversy. Now, what is important is NIH applications, for better or worse, discovery science does not do well. There has to be a guarantee of success. And that's why identifying a gap or controversy as the basis of your study leads to a strong application, because then it's a win-win situation where no matter how the results come out, whether your hypothesis is supported or not, there will be an advance in the field. We will know something that we didn't know before, or we will resolve an issue that has held up the field and has prevented it from progressing in the advancement towards translation or to understanding the mechanisms of a disorder. The aims then are a more specific set of questions of what you will actually resolve. So there may be a broad controversy aspects are you going to look at in your grant application, because you can't look at everything. The hypotheses is what are you going to test? What comparisons are you going to make? And critically, which direction do you hypothesize the results will show? Applications that say we're going to do something and just see what happens and we're going to document whether there's a difference do not do well. They are not considered to have high scientific merit. And when you think about it for a moment, that makes sense, because if you compare an experiment that says we're going to see what happens to an experiment that says we predict based on the literature and our own preliminary results that the results are going to come out in this direction, and this direction will show that this mechanism is operating in this way, is clearly a stronger scientific endeavor than one that we're going to just see what happens. Because if you just see what happens, there's a high risk that nothing will happen or that you won't be able to detect anything. The approach section is how will you actually measure things? What will you measure? How will you measure it? And how will you manipulate your independent variables? The last section is not a formal section, but something that reviewers want to see all the time. They want to see that you've thought through the entire study to its logical conclusion, and that you have considered alternative outcomes. How could the data come out if it doesn't come out the way that you want it to come out? How might it come out? And how would you interpret those alternate outcomes? And what limitations does that impose on the overall interpretations that you will make? This is something that a lot of people tend to leave out in their applications, but it's something that is critical to getting a very good score. Okay, so let me stop for a moment. I've gone through kind of the formal processes of how applications are available, and I want to see if there's any questions at this point.
I have a question about the ABCD study.
Yes.
You said that the imaging data will become available. I was wondering if any other phenotypes will also be available, for example, the genetic data, because that might be difficult data to share.
Yes. The answer is yes. There's already an NIH, there has been a long-standing NIH policy that genetic data has to be openly shared. The ABCD sample will be collecting biological material, including cheek swabs and in some cases blood. There's also going to be a twin component in the ABCD study. However, the funding for the ABCD study does not include the analysis of that genetic material. So it is still being worked out how that material will be made available. The samples themselves will be stored at the Rutgers facility that stores genetic sample or tissue samples, blood, saliva, cheek swabs, for genetic analysis that NIDA has established for a number of years as part of the genetics consortium. And so it is likely that that material will be made available so that people can conduct their own genetic analysis. But the genetic analysis is not going to be conducted within the ABCD study at this point in time.
Okay, thank you.
Hi, relate to the first question. What types of behavior tasks will be administered in the ABCD? And one more question is, who can access the ABCD data? Is there any eligibility for the investigators?
Let me answer the first part first. I suspect that the data access for the ABCD data will be very similar to that of the Human Connectome project. That is, there will be a data access registration and vetting to make sure that people are qualified investigators, but it will not be stringent. Just to make sure that people are qualified investigators and they adhere to personal privacy rules and so on. The behavioral testing and the phenotyping is extensive. It's very deep phenotyping. And what I would recommend you do is go to the ABCD website and track that as the protocols become released. We're still working out the details of what exactly is going to be put into the protocol, into the assessments, to make sure that we can minimize redundancy and keep it down to a manageable level. But it's going to be extensive.
I think we can keep going.
Okay. So now I've given you kind of a formal description of what needs to be in a grant application. Now I'm going to go kind of lift the curtain and give you some personal tips that have accumulated over the years. The first one is this acronym SUCCESS, which derives from a book written by two brothers, the Heath brothers. And the book is very interesting. It's very readable. It's available in paperback. I highly recommend it. These two brothers are both professors at Stanford, and they realized that they were both studying the same thing. One is in marketing, and one is in sociology. The one in sociology studies urban myths. The one in marketing, obviously, marketing practices, branding, consumer outreach, and so consumer recognition, and so on. But they realize they're studying the same underlying process, which how do ideas or brands or stories become embedded in people's memory and stick there despite, for lack of a better word, lack of evidence or lack of comparison or lack of evaluation. So why do people routinely buy Coke over Pepsi? What makes them do that? Or buy a certain brand of clothing? Or why do people believing certain urban myths, even though it's been documented that there's no evidence for this at all? And they came up with this acronym of the characteristics of urban myths or good branding. So it's either a good thing or a bad thing, depending on your point of view. And these are very cogent points for writing a good grant application. First of all, it's got to be simple. this is kind of in your background what you establish in your background section, but it kind of flows throughout the entire grant. You need to explain things in a simple and concise way. I know as scientists, we are used to dealing with things that are complicated, that are difficult, but honestly, when you're a reviewer, you have a stack of applications in front of you that you've got to write evaluations for, and they're each 100 pages long with all the supporting documentation, and they're going to be read quickly. So you need to get your point across strong and fast and in a clear and concrete manner. There needs to be something unexpected about it, something that's counterintuitive, something that makes the reviewer sit up and pay attention. So it can't be, you have to have some elements in there to make it, to differentiate your proposal from everything else that's been done in the field to date. That's the innovation quality. It's got to be concrete. This is where the aims and approach comes in, where you provide the details of the methodology and ways that you're going to analyze the data and the interpretations you're going to give. Credible. That's you, the investigator. That's your track record, your CV, your bio sketch. Do you have a good track record of publications? Have you been funded through other types of mechanisms and successfully completed those projects with significant findings that were published in the literature? Emotional. There has to be something that, again, grabs the reviewer's attention and gets them engaged, that makes them sit up and say, yeah, this has to be done, that makes them passionate about defending this application against criticisms. And finally, there has to be a story. And I can't emphasize this enough. There has to be a beginning, a middle, and an end. And there has to be a coherent narrative arc throughout the application, and it has to read well and smoothly. And I've seen well-written grants that might have scientific flaws get better scores than applications that were scientifically more rigorous, because the one grant had a better story than the other, a simpler, more comprehensive, maybe more unexpected, but credible story. And therefore, I recommend that you always have your application read by somebody else, preferably somebody who is not directly in your field, and maybe even have it read by somebody who is a professional writer or is an English major or something like that, to make sure that it flows well, that it's very readable. You don't want your application to be War and Peace. You want your application to be a beach read, a page turner, that the reviewer says, I can't wait to see what they do in the next section. Okay, so here's another set of acronyms or that have to do with a good application. In a application, you need to show that you have a demonstrated track record of productivity. This includes not only publications, but funding from any source, internal funds, a training award that you may have gotten, funding to attend this course, anything that represents material support of you as an investigator. And this is important because it shows that it demonstrates to the reviewers that you are capable of taking a project from start to finish in an independent way. Pilot data. Now, this is always a big issue because there's the catch-22. Why do I need to have completed the study or initiated the study before I get funded to conduct the study? And this is something that I complained about when I was an investigator, and I fielded questions constantly when I became part of the extramural program. And it took me a long time to really appreciate the rational basis for this. It's because this is the only way, by having pilot data, it is the only way that you can prove to reviewers that the study will not have a high likelihood of a type 2 error, especially in imaging, where we know that there are clear limitations in the sensitivity of our instrumentation, and we're working at a very low signal to noise ratio in brain imaging. There is a high likelihood that your hypothesis might be correct, but you will not be able to detect sufficiently the difference in signal across conditions or groups. And so having pilot data is the only way that the reviewers can be assured that you have the ability to detect a difference and that your proposed sample size is adequate to make that proposed difference reach a statistically acceptable threshold. So that's why you need to have proof of concept or effect in your pilot data, the guarantee of a detectable signal to avoid type 2 error, and a full and well articulated power analysis. This is even more important under the reproducibility and rigor policy, because this the power analysis and the experimental design and the strength of the pilot data speaks to how robust the results will be and how rigorous your analysis will be. Production. An R01 application, which is the gold standard funding mechanism for NIH, is really a data factory. When you get the award, you're expected to hit the ground running, and you have an assembly line operation that's just going to churn out the data that you propose to collect in the application. That's why discovery science doesn't fare well, because discovery science is liable to have too many twists and turns that are unexpected. You want to be able to guarantee, to the extent possible, that you're not going to get negative results and that you'll be able to collect the data in an efficient manner. This is particularly important for human studies. The next P is perseverance. You have to keep trying. You cannot be discouraged when your first application comes back with a poor score, or even your third application comes back to a poor score. In a certain sense, it's a lottery. In another sense, it's like surfing. You have to catch the wave at just the right time. The other thing is you have to realize that, like in baseball, if you have a batting average that you hit the ball 3 out of 10 times, that's really good. 4 out of 10 times is outstanding. So that says in the funding world, in applications, you may have to submit 10 applications in order to get 4 funded, or you might have to submit four applications to get 1 funded. So you have to keep trying. And finally, program officer. I've focused a lot on review because that's the high hurdle. Program officers like myself are your best friends. We're the ones who are going to encourage you in your research career. We're going to encourage you in your research project. We will provide you with guidance as to how to submit the best application and how to submit an application that is well aligned to the mission of NIH and to the mission of the particular institute that we work for. And you may have an idea that doesn't necessarily align with the institute's mission, but a good program officer would refer you to somebody else. So we are the first line of contact, and we are the last line of contact you have. Our job is to guide you through the process of submitting applications, and then if you're fortunate enough to get an award, we track the progress and we handle the administrative oversight, but we're also responsible for publicizing and disseminating your results, not only within the Institute, bringing it to the attention of the Institute director for inclusion in their talks, but to the general public. So if you have an idea for an application, it's the program officer that you will talk to first. Now, one thing you have to appreciate is you're going to have some degree of perseverance, because you may get passed from one contact person to another. This is not program officers trying to decrease our workload, but rather it's matchmaking, trying to get you aligned with the program person who would be most interested in your application and has a vested interest in seeing you succeed and has the proper experience to advise you. So let me stop there and take some more questions.
I just want to point out that these are sage pieces of wisdom, and you know, a certain amount of what Steve is saying, you could say, well, this is, you know, about the R01 mechanism and blah, blah, blah. But really, this is about how do you write a winning proposal, period. It doesn't matter whether you're sending it to the European funding agencies, to the NIH, any of this other stuff. And these are things to really pay attention to. And Steve, you may have noticed, Steve said very little about science in this. It's really is process, it's narrative, it's, you know, how do you market your project?
How do you describe science in a clear and concise way that is going to get a seasoned investigator in the field excited about your project, such that they give it a high, they evaluate it as having high scientific merit and therefore a good investment for NIH to spend money on? Yes.
Hi, I have a question. When you are at the early stages of your career and don't really have a lot of funding yet, especially not grants, should you also include applications where you got into the final selection round or something, or is that a no-go?
Okay, so this is very much like when in your bio sketch. Do you include publications that are under review or are pending accepted pending revisions or something like that? And the same thing applies. No, it doesn't count. So in some cases it might count. So if you say you were a semifinalist for, the Intel, high school science awards. Okay, that has a lot of merit. If you were a semifinalist for your, for the, I forget what it is, the National Merit Scholarships, that counts for something. But to say that you were third in line to be funded, but they only funded 2 applications for a particular let's say internal grant funding mechanism, that really doesn't convey much to the reviewers. What they want to see in terms of your funding record is not only did you submit things of high enough scientific quality to be considered for funding, but that you actually successfully carried a project through from start to finish.
Thanks. Can you say something about NIH application possibilities for foreigners who might work here in the US but are not actual citizens? Because I think quite a lot of us are non-US residents.
Could you say that again? It was a little bit garbled.
Oh, I'm sorry. Can you say something about funding possibilities through the NIH for foreigners who are not U.S. citizens but might work here right now?
Okay, yes. So foreign citizens can apply for NIH research awards. Foreign citizens can get NIH funding to conduct research at foreign institutions. However, there are caveats when money is sent outside the United States to a foreign institution, that there has to be a justification of why what is uniquely available at the foreign institution that would make it difficult to conduct the research in the United States. However, foreign citizens are not eligible for NIH training awards. You must be a U.S. citizen for a training award. Now, like everything, there are exceptions to that rule. And this, the training course that Mark runs is one of those rare exceptions. A special procedure was put into place to allow foreign citizens to be part of the graduate student support for the training program. But that is the exception that proves the rule.
Proves that the exception is actually a good idea, because in fact we've had some extraordinary foreign students come through. Others?
Yes.
Hi, thanks for this talk. I'm gonna go back to the foreign issue. If you are at a foreign, okay, right. If you are at a foreign institution and you're saying, look, there's caveats, those caveats have to be explained in the actual application, or is it to the is the reviewers that can evaluate that, or should it be explicit that it's something that cannot be done in the U.S.?
There is actually a formal section in the application that is required to address the justification for conducting the research at a foreign institution.
I can certainly tell you that as a reviewer, people are more than happy to fund foreign scientists if they feel the science going forward. The committees are friendly to this.
So I have a question about grant reviewing. Like, I'm very new to, I just graduated. So in order to write a better grant, I would like to review more grants. Oh. Hi. So I'm wondering if there are any possibilities for new researchers to be part of a study section or review grants in a way, just so that they know how to write it better.
Unfortunately not. While people early in their career, I encourage them, and the Center for Scientific Review encourages people to be reviewers. That in general, the study sections are made up of people who have faculty level appointments, so they're not trainees anymore, and they have a track record of funding, preferably usually NIH funding, and usually an R01, that they have successfully received an R01 award. So that severely limits the ability of graduate students, postdocs, and other trainee levels to be part of the NIH review process. That being said, it is not difficult to set up a peer review system among yourselves. And this is something I've encouraged training programs to do, to have people write mock applications or real applications if you're applying for a training grant, and then have establish a study section of your peers where you swap the applications, you review them according to NIH procedures, and there's actually videos of mock study sections on YouTube and on NIH websites, so you can see how it's done. and go through the formal evaluation process so you get used to this, because you are correct in your desire to be part of review. There is no better way to learn how to write a compelling application than by reading and reviewing and criticizing other applications.
Each of you, or probably each of you, has a PI in your laboratory, and most of your PIs will have sat on those study sections. And there's really nothing wrong with every time that person is away for a week, and when she comes back, and you say, so how was it at NIH? Get a blow by blow. It's really valuable. You'll learn a lot.
Yes, that being said, Mark, I just want to state that reviews are confidential and applications are proprietary. So you can ask for kind of a gist, but you can't ask for specific details, and you certainly cannot ask about specific applications. So you can't say, a friend of mine had an application, how did it do? That is completely verboten.
And nor am I being reprimanded for that. That's not how we do it in my lab meetings. Anybody else while Steve is still here? Yeah.
And let me put up my contact information again, and I'm happy to get emails or contact me. The best way to contact me or any program officer is by email. And even if it's not an area that is germane to NIDA or my particular area of expertise or portfolio, I'm glad to provide you with an initial contact and guide you to a person who would be most appropriate for your research.
I was wondering if you could speak a little bit about training plans and what the NIH is looking for in those.
In training applications?
Yeah. So for trainees, when we're talking about
Okay,
our career
so
development or something.
in a training application, whether it be pre-doctoral, postdoctoral, or mentored career award, what they are looking for is a clear description of the concrete skills and expertise that you will acquire during the training period, and the timeline and the activities that you will engage in to acquire that training. When a training application is evaluated, it is evaluated primarily on your strengths and weaknesses as a training candidate, in terms of the likelihood of you having a successful career that's going to make a high impact in the field, and the secondarily, the training plan, your qualifications, and then secondarily, the research plan. The research plan, flaws in the research plan in a training program, a training award, often are forgiven because the training plan is limited, the training activities are limited, and the training activities are there to provide a hands-on way for you to exercise the new skills and abilities that you are going to be trained in. So there's a little bit, not much, but there's a little bit more leniency given to flaws in a research plan when you have a training application. It is critical in a training application that you provide the reviewers with a clear description, not only of the skills and abilities that you're going to obtain, but how that those skills and abilities are something that you do not currently possess. So a training application that says, I did this in my postdoc, and now I'm a faculty member, and I've got a mentored career, I'm coming in for a mentored career award, and I'm going to do the same thing I did in a postdoc. That will not get a good score, because it's assumed that you already have the adequate skills and expertise to, from your postdoctoral training, to do that level of research. So you have to articulate what is missing from your toolkit, so to speak, that keeps you from going on the career trajectory that you've set out for yourself. And then how will those gaps be filled? What activities will you engage in? Who will mentor you? Precisely how will they mentor you? How often will they meet to you? What advice will they give to you? What will go on during the mentoring sessions? How will you gain expertise in the literature in the field? How will you gain hands-on expertise?
A follow on to hers. Okay.
Just one follow-up question. Do you actually need to submit pilot data for a training grant?
Again, there's more leniency on that. And in general, pilot data is good. But like I said, there can be more leniency given in a training project. But be sensitive to the orientation of review, of skepticism and a fear of failure, that they will look at that research plan and say, why won't it work? What things aren't going to make it work? And if you don't have pilot data, then the more comments you're going to get about why it possibly won't work. And as you all know, there's a million reasons why something won't work. So it's a little bit of a risk. It's less risky than with a research application, but it does pose a risk when you're putting in a training application. The amount of risk depends on what is in the training, what is the research project, how much you're building on your mentor's research, and so on.
Thank you. One question, any advice? I'm a postdoc trying to decide between a K award and a K99 ROO, R00. Any thoughts on which is better, which is more likely to be funded, or which will give me give a person the trajectory?
Okay, so a K99 R00, the so-called kangaroo award, was established to fill a particular problem in the academic field, in the academic career trajectory. And that is, you can be an outstanding postdoctoral trainee with multiple publications in the top tier journals and multiple awards, from foundations or scientific societies. And reviewers will still look at your research application and say, how do we know that you can do this on your own? That's one part of it. The other part of it is when you apply for a job, those candidates who have a track record of funding, and especially those candidates who have an award, already have a funding award, rise to the top of the pile. They inherently rise to the top of the pile and are considered to be the stronger candidates. So this puts new investigators at a disadvantage to get a job and impedes the trajectory of the careers of the upcoming generation of researchers. And it narrows the pipeline. So the K99 R00, which is formerly known as the Transition to Independence Award, allows someone, while they're still a postdoc, to get a little bit of funding for continuing their postdoc while they're looking for an independent investigator job, faculty level job, and be able to say to the institution they're applying to, I have funding in hand. I have a research grant, the R00, in hand, guaranteed that I will bring to the institution. And therefore, it puts you on this, it levels the playing field with people who are 2 or 3 years out of their postdoc who have gotten a track record of awards. The mentored K awards on the other hand, are for people who already have a faculty position. And they see a need, as I said before, to fill in a gap in their training. So they've been trained in neuroimaging, but now they want to pursue integration of neuroimaging and genetics. They know nothing about genetics, and they're going to be mentored by a faculty member at their institution on how to conduct human genetics research, or the other way around. And so that's what a mentored K is for. A mentored K is not for your salary when you're on soft money, when you're in a position when you are expected to raise your own salary. That is an insufficient justification for a K award. It has to be training in a new skill or area of expertise. And you have to already be a faculty member or have a guarantee in writing from a chair or dean in your application guaranteeing you that faculty position whether or not the K award is funded. It cannot be contingent on the K award. Does that answer your question?
She's looking grim, but yes. Steve, I know that you had a meeting that started 15 minutes ago.
Yes.
We really, really appreciate that you're spending so much time on this. Your commitment to young investigators is legendary, and this just shows more of it. And I just want everybody to thank Steve for taking all the time.
Thank you for your attention. And keep in mind, I'm from the government. I'm here to help, and you are my customers. You pay my salary. So don't hesitate to contact me or any other staff member at NIH if you ever have a question. All right. Thank you. Bye.
Test 1 2. Testing 1 2.
So the next, we're sort of moving naturally on to stuff that is very you-focused, and the next thing we're set up for is a panel of young investigators and sort of for career advice, a mixture of young investigators and established investigators, the point really is for you to be able to ask questions about what you can do to continue developing your career and get some sense of how people who are at least moving forward are getting things. And so if I can have Leah and Jen and Carolyn and everybody come up to the front of the room. Oh, okay, great. Yes, I think that's right. Yeah, okay. I thought Jen Silvers was coming, so I was confused about that. That doesn't seem right. Martin would know, but anyway, I mean. That's fine. We have great people. Okay, I know that somebody put out some savory snacks there, which is great. But we actually, I know you also want to be able to have plenty of time for your debates, and so let's get your attention over here. Hello. I just want to actually go ahead and have our panel quickly introduce themselves. Two of them you know, but here we go, Laura.
Hi everyone, I'm Lara Ray. I'm a clinical psychologist. My program of research is in addiction, and I graduated at the University of Colorado Boulder in 2007. I did a postdoc at Brown University for 1 year, and took an assistant professor position in clinical psychology here at UCLA in 2008. And since then, I've been promoted to associate, and as of 3 weeks, I'm a full professor, so I'm excited. So thank you. It's been quite the ride. I do have 3 children, so if people have questions about balancing work life, I have twins. They're 3 years old, and I just had a baby 3 months ago. So it's kind of a full life, and I'm happy to answer questions and to be here with you.
I'm Carolyn Parkinson. I was actually an NITP student in 2013, and I'm a new assistant professor here at UCLA. I started in spring quarter in the social area, and I just finished my PhD in cognitive neuroscience in, I guess the fall of the spring of last year, and did a brief postdoc, and then came to join the department here, and I study basically the neural basis of social perception, and I guess the job search is still pretty fresh in my mind. So if you have any questions from the perspective of the candidate applying for positions or navigating the interview process, maybe that's would be most helpful in terms of answering your questions.
Right, so I think I've met most of you. Martin Monti, I'm here also in the Department of Psychology. So I joined here in 2011 as an assistant professor. Before that, I was a postdoc for 3 years in Cambridge. And I am an ITP, that's right, grad, alumnus. I think 2008, maybe, 8 or 9. I never mentioned I work on the neural base of consciousness in patients who lose consciousness because of traumatic brain injury. You've heard Julia, we work together on some things, so you've heard some of what happens, some of the cool stuff that happens in my lab. And as of 3 weeks ago, I'm actually an associate professor. So, should you have questions about tenure, I remember that.
And I'm the token old person. As you know, I'm Susan Buchheimer. I received my PhD in clinical neuropsychology in 1988 and was at the NIH as a postdoctoral fellow and senior staff fellow for 4 years before coming here in 1993. My work is on, well, I started out actually as a PET researcher before fMRI was invented, and then started doing fMRI work when that started. My background is, since I'm a clinical neuropsychologist, my background was in epilepsy, and particularly pre-surgical and intraoperative mapping of language and memory. And my lab now focuses on a variety of different areas, developmental disorders, particularly autism, memory and aging, and I continue to have a clinical program and a research program in pre-surgical planning. I'm a tenured professor with an endowed chair, and I have 2 children, so I've been through like all of it. So grants, every kind of grant. So any questions you have about that stuff.
So if Susan is the token old person, I'm the token fossil, and I'm a professor at UCLA. My research has been heavily focused on technology and its ability to go and work on brain function, and I was involved in fMRI when it was a glimmer in somebody's eye, and have been here for a long time. And there's a little story that Dan Dennett talks about a fish that after it's born in its embryonic stage, it swims around until it finds a piece of rock to land on, then it permanently adheres and absorbs its brain. So, please, questions for our panel.
Ed in the back.
Oh, yeah, we need the roving mic, I guess.
Hello. Oh. And in your experience, what do you think is more likely to get you a job? Like a researcher with a lot of publications, or somebody coming in with funding?
God, I really wish I could say research publications.
I think my view is that it depends on the type of job you're going for. In our psychology department and a lot of tenure track positions, the funding is less relevant than the impact of your science. That being said, of course, you know, there are a lot of great opportunities once you are established in your career to pursue funding. So I'm biased towards, you know, the psychology model in the sense that it gives you room to explore your true interests while also, you know, supporting you financially and allowing you to then, you know, parlay your interests into proposals. I worry a little bit about my colleagues who went the medical school route. Not all, I would say there's brilliant, you know, medical school scientists, including some in this panel, but I worry that some of them had to turn their research interests into things that they weren't quite as interested in. So there's been a lot of movement in their research to accommodate funding. And I think, you know, that's not universally true, but my experience is that I was able to pursue what I was really interested in. But to your original question, I think it really depends on the type of job you're applying for.
Just to follow up on that, if you're applying to jobs in medical schools, they almost never have hard funding, at least permanently. Sometimes they'll give you some startup, but they don't tend to have hard money lines. They expect you to pay your own salary and grants. So if you're looking for a job in a medical school and you come in with a K grant or a K9900, that's going to be looked on very, very favorably. That said, you can't get any job without papers these days, and good ones. It's just getting increasingly competitive. But if you're going to go the medical school route, so perhaps going into a psychology department or going into a department that has hardline funding is not an option for you based on your background, then having funding is extremely important. At the same time, you can't get funding unless you've been productive, so you basically have to work a lot.
I'll also chime in and say that that having skills is really, really important when you're coming into a lot of faculty positions. They're looking for somebody who's going to flesh out their team often, and they're looking for people who have very specific skill sets. And I can tell you that I had a tenured position here before I had my first grant. So, you know, I mean, it can happen all kinds of different ways.
You guys are talking about hard funding and soft funding. Can you just differentiate that very quickly?
Hard money is a salaried position. So let's say in the psychology department and in many academic departments, which are 9-month appointments, that is, you've got an academic year, they have a hard money, which is you have a salary and you're going to have that salary until you either don't make tenure or you do make tenure. So it's a certain percentage of your income. In academic departments, it's usually 9 months of salary. And in the rare, and that could be 9 months of all of your salary, and then your summer salary can be made up of grant money or a combination of grant and teaching. In medical schools, they don't pay they don't have a hard money that you will just have no matter what. So what they tend to do is to give you startup money, which is money provided by the department, which once spent is gone. And then your salary is zero unless you've got grants to support it. So grant money is considered soft money. That is, it's there as long as you can pay for it, or it's startup money, it's there for as long as it lasts, or it's foundation money, it's there until you spend it. But once the grant is gone, the salary is gone. So that's the difference between hard money and soft money.
Hello? Okay. So I guess we've been hearing a lot about how hard science is and how much failure and rejection there is. And I guess I'm just curious about how... Yeah, I know. Right, and well, we're all like young scientists, and I guess I'm just curious how you guys push forward and remain optimistic and keep trying innovative things in the face of all this rejection.
Probably everybody has their own approach. You want to start, Carol?
For me, something that really helps is having multiple independent lines of research so that if one is really frustrating or stalled, hopefully there's kind of more light at the end of the tunnel and some other set of projects that you're working on. Just within the sort of sphere of work, I think that really helps. And then also, you know, balance is important. Like just having some kind of outlet because it can be really tempting to work all of your waking hours, and because there's no real limit to when you should be working, I guess, if you're in the tenure track or wanting to get into the tenure track, but sort of maintaining some sort of time to do something that you like that isn't research, I think also helps.
If I may add one thing, a number of very successful people in academia have started, it has become fashionable to release a CV of failures. And I just happen to have read recently the one of a Princeton professor. Read it. You know, they fail just as much as you and I, and everybody else around you also fails. You just get to see the grants they do get. So just know that we all kind of swim in the same water. Be persistent, and you gotta love what you do, I would say. It's a labor of love, from my point of view.
I often tell my students that you shouldn't go into science unless you're driven by the power of Satan to do so, because there is so much rejection, and that's part of it. And so the first thing that you learn how to do is to be tough and to not be swayed by rejection, because you're going to get it. One of my advisors in graduate school said that the way science works is you come up with an idea, you put it out there, and everybody in the world tries as hard as they can to shoot it down. And those ideas that survive this horrible onslaught are the ones that go ahead. And that's really what science is about. The nature of science is to be critical. And so learning how to cope with rejection is one of the, in my opinion, one of the first lessons you need to learn how to throw it away, not take it personally, and keep going. One of the things that I did early in my career, I asked a friend, like, how the hell do you manage to throw these papers out and write these grants with all of this rejection? And she said, I write a paper and I send it to the scariest people I know and get their comments on it, just to desensitize yourself. And so I started doing that very early on. And it desensitizes you when the most famous person that you can think of gives you a critique. And you know, it's harsh, but you have to learn how to brush it off and keep on going. Otherwise, you'll just have your feelings hurt all the time, and it's really hard.
Just adding to what Susan was saying, it really took me 5 years to get my first R01, and I was up for tenure before my R01 was officially funded. I personally enjoy writing papers more than I enjoy writing grants, so I've just been very happy to write a good deal of papers and have fun with that. I think that we have to look for the reinforcers along the way. It's really fun to see our students write their first paper, get people excited about research, go to conferences, see the impact of our work, and the grants will follow. It really took those 5 years, and then once that happened, I got a good number of grants, more than I could manage in a sense, and you can't control those things. Sometimes it's too much, sometimes it's too little, but I keep in mind that I might have 3 R1s today and 0 next year, and I'm still the same person. It really doesn't matter if I have 3 R1s or 0. It's really my thinking and my science and how other aspects of my life are also evolving, like relationships and family and so forth.
So I guess this question is probably at a different level. When you're starting a lab, or even when you have a lab, what is the best ratio between postdocs, grad students, RAs? I guess having a postdoc is great. You don't have to train him, but he is independent, and so whereas having a graduate student, 4 years in the process. So that's one question. The other question is, how do you ensure that when your grad student is out, that he is going to be scientifically independent and not just doing your work? So in a sense, when you're training someone, you have to think about, okay, whatever this guy is doing, this person is doing, when he gets out of here, he should be known for that and not just me. So how do you deal with that?
So the first part of your question is different people. I bet every single one of us on this panel will have a different opinion about that. Some people really like postdocs, some people really like RAs, and some people really like graduate students. I like graduate students, and I like RAs, and I occasionally have a postdoc. But other people will only do postdocs. So it's really just a matter of what you like and what you want. And I don't think there's a correct answer to that question. For the reasons you suggest, well, first of all, graduate students are with you for a long time. I really like mentorship. You know, you teach them, you bring them up, they become your family. They're dedicated, they're hardworking. They're working on your stuff, but also on their stuff, so there's a nice balance there. I just personally find it very rewarding. I've had great postdocs too. I don't want to say that I haven't. I've had great postdocs. They are launching their own careers, so maybe they're going to be a little less engaged in what I'm doing. Other people will comment on this, but let me just comment on the second thing. There's nothing that you can guarantee about your graduate students about what they're going to do, and I would never worry about whether they're going to be doing like too much of your stuff. You know, there's always room in science for more people to study what you're studying, and you know that's great. It's really on them to develop their own direction, and as a mentor, one of the things you want to do is to help them to do that. But usually that, if they're a graduate student, that means directing them towards a postdoc where they're going to learn some new skills and help them to define a niche for them that they want to do that's going to go beyond what you've just taught them. And that's just part of the mentorship process. Learning how to be a good mentor means helping your student reach a place where they can carve out their own niche and be independent.
I really like postdocs, and I have as many postdocs as I can pay for. In a sense, at least from my point of view, you'll have to ask my lab members if they feel that they're just all your children, and it doesn't really matter. You just interface with them slightly differently. So I will sit with the RA and we'll go over code and sort of, here's how you write a loop. And with my postdoc, we'll be usually she'll be teaching me DCM. But what does this mean exactly? And sort of, so it isn't really, sort of it's like a big family. They're all your children. You love them all in a slightly different way. And you talk and interact with them in a different way. I only have one recommendation, that you always try to, if you're hiring people or getting people in here, you always try to hire people that know something more than you do. Because else it's totally boring and they can only be as good as you. And instead, if you have people that have extra things, that have experiences you don't have, you always together end up being more. And it's true also for incoming grad students. One of mine is down there. He knew stuff that I didn't, and I really liked that. I was like, oh, great, I can learn this. So.
And I think I have found that as I've moved into, you know, as you get more senior, you have less and less contact with your data, and more it's your students and your RAs who are doing it. And there's no, it's an unfortunate part of expanding and growing that you lose track of that. So I have found that the most important thing is to have at least one person who's with you, who's going to stay with you, who is well organized and who can help you manage things and stay close to things. So there are a couple of people that I've had over the years who've just been, I've got one person who's been with me for 20 years. And it's good to have somebody around there who can do that. And the other thing is I would say is that I look for graduate students who are independent and resourceful. Same thing with postdocs. You want somebody who's going to be able to solve problems for themselves. Otherwise, you're going to be spending every second, with, trying to solve small problems that somebody else could solve. And it's also better for them because they need to learn how to problem solve for themselves if they're going to be independent in the future.
I've been here for 8 years and I've had 4 postdocs. They've stayed for multiple years, but maybe this is my own clinical issue. Susan can help me with this. I feel a great sense of responsibility with the postdocs and their careers. So it's a little more about them than it is about the success of my lab. And that's different, and I know in some labs and different fields have a culture of asking postdocs to do more.
if you want a postdoc mentor who's not going to ask you to do a lot on their research, that's me, because I do feel like, you know, you're trying to build your own thing, and the more that I'll give you opportunities, I'll ask you to look at data, but you'll be first author on these projects. So I think in a lot of ways, I think more about kind of sharing and taking a lot of responsibility. When they start writing K awards, is especially painful because, you know, you're going to be evaluated as a mentor. You have to have funding. You know, even if you have funding, they say, are you the perfect mentor? I mean, there is a category on mentoring, you know, and so there is a lot of responsibility that goes with it if you are kind of supporting that person, launching that person. And there are things that as a starting investigator, you're less poised to do. Now, other folks are going to go to tenure track positions, and you know, they're more interested in learning skills from your lab. But a lot of folks, especially in medical schools or, you know, in the clinical field, they want the postdoc to be a launching pad. So you have to really align their goals with your goals. And I agree with Susan that with grad students, the contract is very clear. You know, their goal is to graduate, to learn, to be successful. It's a little less clear with postdocs, and evolves, you know, as you know.
I'm glad that Laura actually brought that up, because I was going to say something like that. I think it's a mistake to imagine that your job, PI, is to hire people to serve you. That's not what's happening. Your job is to serve the people who work in your lab. Your job is to help them create their career. You know, if they compete with you, that's great. You know, it's only more credit to you that you found somebody who can go ahead and great. And when you talk about whether you should hire at the postdoc level or at the graduate student level, I think that one way to think about that is the change in your responsibility. That is, if you're taking on graduate students, in my opinion, your job is to actually try and help people find problems that are worthy of their time. That you're trying, I mean, people come in with technical skills, they've got some chops in physics, or they've got some chops in genetic, whatever it is, but you know, as you mature in this field, you should be thinking more in terms of, you know, how this work is going to have an impact on not just your career, but on maybe healthcare, on maybe important questions in science. With postdocs, the responsibility is different, right? With postdocs, you're thinking about placement the moment they walk in the door, as far as I'm concerned. And you know, I mean, I guess I always tell people who come into my lab, and I guess nobody in my lab is here to deny it right now, but I try to treat people as my younger colleagues, right? They're not serving me.
Research assistants, on the other hand, their job is to just help you. And you always need a couple of those. You know, it's just somebody who's going to do your stuff for you and nothing else. Except all of them want to go to graduate school too, so.
Okay. One thing I was recently worrying about was how to balance. So I study something very specific, and I'm worried that I'm going to spend my graduate year studying this very specific thing, and then I'm going to apply to postdocs, and there's going to be no options because they want someone who studied something else, or everyone wants the person who studied the thing they're studying. And I'm trying to figure out how to balance those two things, because on the one hand, I want to be well-rounded and learn a lot of different techniques. Do you think it matters when you're applying these things what you actually studied, or is more important just the skills you got from it and to show that you can then apply these to something new? That's my question.
I changed completely fields. I was doing neural basis of deductive reasoning as a graduate student. I entered a lab working on patients in a vegetative state as a postdoc. What I think got me there, I never quite sort of asked what is the one thing, was the skills that I had learned along the way, which you're learning too, and which I do my best to make sure my graduate students learn whatever they'll be doing after. And I don't think you can really anticipate. All you're doing, I think, in graduate school is you're committing to a certain area for a little bit of time. I always tell incoming students that should they ever be very unhappy with me or discover that really low-level vision was what they wanted to do, there's a mechanism for doing that. You're not stuck forever. But it's the skills and a way of thinking that is really what you're learning. You're learning how to be a junior investigator, and that's what I sort of, when I relate sort of with my lab, that's what I have in mind. I like trying to turn into a junior investigator, and then they'll go on to do, maybe their interest will change, or they'll discover one tiny blip when they're working with me, and that will be what they'll be really interested, and they'll move on, or who knows. You can't anticipate all of it, I think.
I mean, the fields change, over the lifetime of your career. What kind of work you're doing is going to change. I mean, when I started out, who knew that there was going to be fMRI? I sure the hell didn't. And 10 years from now, who knows what there's going to be. I think that the best graduate students I have are those, and they obviously have their thing that they're working on, they've got their area, but they find their own ways. Like my graduate student will tell me, oh, by the way, I'm collaborating with somebody else to do this other project. And I said, great, that's fantastic. Find your little side projects to do, and they do it completely independently. I'm not even on those papers, which is great. And I don't think it's of course, I'm in the extreme version of casting a wide net, because I just do like a gazillion different things that are completely unrelated to one another. But I find it to be rewarding. But most of all, I think it gives you the flexibility to go where, sometimes where the funding is, sometimes where things get interesting, and sometimes because the field is going to change in ways that you will never know. So I think it's good to be a little bit, to keep feelers out, and to have alternate, several things going on at the same time, even if it's in a small way. And as Martin says, it's your skills that will take you and in any different direction.
One example I can give of this is when I was a graduate student, I did a lot of work in behavioral genetics, and University of Colorado has an Institute for Behavioral Genetics, so I was pretty involved with that. And then as I took my first faculty position, or my only faculty position here at UCLA, I realized that the field was moving towards larger and larger data sets. And as a young investigator, I didn't have all the connections to large consortia and to really follow some of the techniques that were evolving. I didn't have the financial resources or the connections to be a part of those large programs, but I had a lot of great interest in some more mechanistic questions. And then I really refocused my program on mechanistic questions, combining pharmacology, using neuroimaging, using genetics, which I think pharmacogenetics is one of the areas I'm best known for. But really, a lot of students come to me and say, "Oh, Lara, let's study behavioral genetics." I was like, "No, you're in the wrong lab." I have to be forthcoming and saying, like, this is not an ideal fit, and here's why. Here's where the field is going. Here's where my lab is. If you want to be at the front, the cutting edge of that field, you're looking at the wrong advisor. I mean, I love what I do, but I can't misrepresent it. So, it's very different from, some of the things that I studied at the University of Colorado. Of course, I could do twin analysis forever. Personally, I'm not that interested in them because I think there is a bit of a ceiling to the kinds of questions they can answer. So you'll be faced with some of those questions rather quickly, and it hasn't been too long since I left graduate school.
Another thing I would add, just in response to your original question about basically content versus skills, because I'm interviewing postdocs right now, so this is sort of on my mind. And in addition to what Martin was kind of saying about, being able to apply the same skills to a different problem being really advantageous, more so than being an expert in some sort of small area of the literature. Something else that really sticks out to me about some applicants is just, even if they're not using the kinds of methods that I use, just if it seems like they're able to sort of independently learn new methods and also maintain a really sort of productive track record, and sort of seems like they're, have a really great work ethic and are also really able to sort of think critically, have independent lines of research going on, and also be really active in applying for awards and submitting papers and things like that. Those are all things that'll benefit you no matter what lab you apply to, and will, I think, stick out on an application to any PI, even if they're using different methods than what you use in your lab right now.
Sorry, I just wanted to add real quick, like the one thing we know in psychology is that past behavior is the best predictor of future behavior. So if you're looking at a postdoc, you should have a good 5 years of past behavior, and I would really focus on that. I've had people that come to me and say, "Oh, I was so not productive with my grad mentor, but with you, oh, I'm gonna write 10 papers a year." not going to happen. So I would really focus on the past behavior and pay attention to that. There might be exceptions to the rule, but it's a pretty robust, finding in our field.
I want to shift the discussion a little more to application for jobs and what you should focus on highlighting in your CV. Of course, there are normal things like what you publicate, but the unnormal things like what is not so obvious, like grants you applied for, but maybe you didn't get because, I mean, we're just starting on and we don't have a list of 500 grants we got. So what should we highlight? What should we also think of highlighting to sell ourselves at the first stage? And the second question, I'm looking at the job market and I'm not really sure that the descriptions are very general. And I'm always like, oh God, that doesn't fit at all. So what should you think of be fitting? Should you contact the people beforehand? Shouldn't you? Yeah, stuff like that.
I haven't seen any CVs people submit for job search when people were sharing their materials with me when I submitted my materials where grants that weren't awarded were listed, but you can sort of bulk up that section of your CV by applying for awards and smaller grants from foundations or your institution that might be easier to get, and that might be a way to add to your CV. And I did contact a couple of the chairs of search committees when I was applying, because I applied to a couple social psychology positions and I wanted to know if a neuroimaging person would be appropriate, for instance, and I think that's totally reasonable to do. At least it didn't seem like it affected my application negatively. I wouldn't bombard people, I guess, with emails and a lot of questions. But maybe people who've served in search committees might be able to speak to this from a sort of greater breadth of experience.
I think I was on hers and you were on mine. So sort of there's a full line here of people who
I've never seen a CV that had grants that were submitted and not funded on there. I wouldn't recommend it. On the other hand, if you've got grants under review, I think that's very important because it shows that you're being active. You've got a bunch of stuff out there. And you should always have a bunch of grants under review. You write a grant for NSF, you modify it for the NIH, you modify it for a private foundation. You just get them all out. That looks good because that tells the committee that you're active. Showing them what grants you didn't get funded for shows them what you failed at. I don't think they want to see that. So I would just do whatever is in process. And jobs are very competitive right now, so they're going to be doing initial screenings on things like, how many papers you got and how many grants you got. Other things that really help in the job market is if your advisor knows anybody and sends them a private note in addition to their letter. There's nothing like a personal contact. I know that if somebody I know and respect very highly in the field sends me a note or calls me up and says, by the way, my student X applied for this position, just want you to know I think that person's terrific, that helps because it makes us look twice. Letters are important, and you would be surprised at how many applications we get with letters that are poor from someone's advisor. So it's or somebody they've worked with. So you don't. I'd talk to your advisor and make sure that you understand what kind of letter your advisor is going to have a frank discussion about. What they think of you and what kind of letter they're going to write, because it's possible to get a bad letter from somebody, if not your advisor, maybe somebody else that you've worked with in the past. So I think that's important as well. And I think it's perfectly appropriate to contact the committee and ask them if they're interested in somebody with your skills and abilities. Often the job descriptions are very general, and that's usually a good sign. It means they haven't already decided who they're going to hire. So I would go ahead and apply anyway, because I've certainly been on search committees where we had a certain kind of a person in mind, wrote a general description, and got somebody completely different, but they were so good that we wanted them anyway.
Susan's comment about letters, I just want to underscore 1,000 times, right? If you're going to get somebody to write you a letter, call them up, email them, say, can you write me a strong letter of recommendation? And if they can't, if they come back with something that says, oh, I'm kind of busy, or I don't know you very well, don't even think of it. Doesn't matter how famous they are, because there's nothing that will kill you worse than a letter that says, you know, Dr. C was in my lab for 12 weeks.
I'm just curious to hear your thoughts on the feasibility of partial or exclusive private funding for research, and the feasibility of getting your research accepted by the scientific community. And yeah, whether
like foundations and sort of non-federal grants.
even more than that, just companies. Yeah.
It is really, really important these days to be broadening your ideas about what constitutes acceptable funding. And if you want to live your life on NIH, it's getting to be a pretty thin stream. So yeah, you should be thinking at all times about anybody else who might want to fund that work, as long as it's the work that you're interested in doing, right?
That said, I think you want to cast a wide net. I do know, for example, one person who was funded by a private foundation for years and years and years, seemed to be that foundation was completely committed to them, and then all of a sudden they had a change in CEO and a change in plan, and funding dropped like that. So for all of your funding, you always want to cast a wide net. Apply to NIH, apply to NSF, apply again to NIH, apply to private foundation, apply to the NIH, apply to another private foundation. You should have stuff out there all the time. And nobody's going to, unless you're getting all of your money from a drug company and you are spouting off the importance of that drug, nobody's going to criticize you for that. Where do you find sources of private money? So many of your universities will have research centers where they keep these things. Our dean's office sends us out announcements for grants. There are many that are in your particular area. So like if you study autism, you Google Autism Foundation grant and you'll get 6 different foundations that do it. There are lots and lots of them out there. A lot of them are very small, but I wouldn't be shy about it. But your university is probably your best resource for that.
In the vein of funding, what do you guys feel about sources like experiment.com, which are crowdsourcing platforms related uniquely to scientific funding? Like, how would that be viewed when you're applying for something like a postdoc or a job? I would imagine that, and for those of you that aren't familiar, it's literally what it sounds like. You design an experiment and you post it, and then people can donate to fund your study. I would imagine on one hand that could be viewed as someone being really driven, but on the other hand, you could sort of look at it and say, all right, well, why didn't you get funded from someone else? So I want to know your guys' thoughts on that.
It's the same answer. Get money from wherever you can and don't rely on one source. If all of your money is coming from one source, it's just not a secure living.
If I may, when you're applying for stuff, it's such a large package that you're submitting, your publications, what you've done, the who knows conference, travel money you've got, grant here, grant there, where you were. There's so many factors that it's rare that there's one that literally people go like, oh my gosh, he got this. No, we can't. So in a sense, these are all, little bricks in your kind of big application. Don't fret too much about sort of.
If somebody came to me with that, I would love it. I mean, I would look at this and say, here's somebody who is out of the box thinking about how they're going to get their work funded. And there's this other piece of it, which is that you've now convinced a lay audience, right? And that's impressive, because the fact of the matter is that you guys pay my salary, right? You're getting money from the public, and if you can communicate to the public the importance of what you're doing, that's a huge plus. And the other thing is that if you publish the paper on it and it's a good paper, I really don't care who paid for it.
Although for everyone like him, there's an old on the committee that is thinking, oh, I've never heard of thingy.com. What is the internet?
Yeah, those guys will retire. Those guys will retire soon.
was wondering if you could talk a little bit about the breakdown of the job talk, how much time you spent on discussing your research, your past research, and how much time you spent trying to convince them that everything you're going to do moving forward is what they need at the institution.
I was given pretty consistent advice to spend about 10 or to 15 minutes, but not more than that at the end, probably closer to 10, talking about future directions and to keep that section pretty broad to show that you have sort of a research program in mind rather than just a couple studies that you want to do. So I spent the most of my time sort of on sort of 3 related studies that I thought were most illustrative of the kind of research that I had been doing and were sort of emblematic of the kind of research that I wanted to continue doing once I started my position. And I was also strongly advised, just in terms of divvying up what amount of time you're going to devote to what in your job talk, to leave time for questions, because a lot of people have to leave its 4 p.m. job talk right at 5, and I think it's really important to show that you can think on your feet and engage with people who are critical or curious about your work, so to leave at least like 10 minutes ideally, so you're not too rushed when it comes time for discussion.
If you have a science paper, you can spend the whole time on it. So the thing is, there is a lot of timeliness to this. You know, I especially for R1 institutions, there is a lot of timeliness to this. I really feel like I was fortunate that my dissertation came out in JAMA Psychiatry, and that's, you know, a big part of why I got an interview at UCLA. So the timing is really critical. And it's not the timing of postdoc mentor, it's your own timing. So when things look right and you have your paper and you have your findings, just go for it. Or if the right job comes up, it's close to your family, it's the right institution, just go for it. And I underscore what Carolyn is saying, that we don't want to spend too much time on what we're going to do, because we're going to sound like a politician, right? Like, oh, I'm going to take care of all violence, you know, like we're hearing that. So we really want to showcase what we have done in our thinking, and then say, you know what, this has legs. This can go a lot of different and exciting ways.
You have to do what Martin did. Martin came out on the front page of many newspapers the day he came in for an interview.
No biggie. If I may have a suggestion that is not that, keep in
But it
mind,
helps.
It did help. When you're doing this, you're talking to a group of people, one of whom in the room is in your area, everybody else has no idea about your methods. And most people around you just want to know that they're hiring for, you know, at least 5, they're committing to 5-7 years of having you in that department, and think that you can be a good colleague, a good scientist, you will be, you know, a good citizen of the department. Think of it as because you're walking into it thinking, I have these 3 papers published in, you know, Journal of Neuroscience, tics, and cerebral cortex, right? That's how she came in. I was like, wow, she didn't even graduate. All right. So, you know, and you're thinking it's just that. It's a bit more than that. You know, they want to know that they can talk to you, as she was saying, that they can ask questions, and you can explain in a way that the person, that, you know, people not in your field can understand, which is very important. I have seen candidates who spoke to me, and I thought they were speaking a different language. Right? That's no good, because now you're thinking about teaching. So it's a science is the heart of it, but there's a lot around it. And if you're a woman, have comfortable shoes. You'll be walking a lot.
Especially because a lot of the interviews are like in January, February. And in the Northeast, a lot of times you get like a campus tour, like trekking through the snow. I ruined my interview shoots. One of my interviews.
Have a granola bar, because you'll be talking while the others are eating.
I'm from Canada. I'm well prepared.
In much the same cynical way I suggested about the letter writers, try to take a moment to figure out who's in the room before you get into that room and what they're interested in. Because people, when they hire you, are taking a big risk. And, you know, we've taken on faculty and said, oh my God, how can we get rid of this person, right? And people really want to know that you're in there because it's going to help not only the institution out, but them. And so, you know, if you happen to have read something cool about their work, comment on it.
And another thing is you might want to sort of titrate how much time you spend on future directions and how much time you allot to discussion if they have a chalk talk, which a lot of schools tend to have these days. In many institutions, it's just like an hour just with the faculty where they're just asking you questions like the morning after your talk. And so then you wouldn't need to spend as much time as I mentioned on future directions and discussion.
So let's do one more question because I know that people want to move on.
So I'm wondering, when you're just starting up, you have these students who come to you and you're mentoring them continuously. And the field is moving so fast that whatever you suggest them today is going to go wrong in 6 months. So how do you stop doubting yourself at every suggestion that you give? Because I might be wrong in once I suggest someone something, and then how do I sleep at night that it might be wrong?
You're not going to sleep.
For one, I have this thing is 3 models old. It works great. Okay, I can do all the things I need to do. Graph theory, some of us here do that. And every 2 papers, it turns out that all the papers before were wrong. At some point you have to do something at the best that you can with the tool that people have so far agreed. I mean, for what we know, fMRI is completely wrong, and it's about the liver and not the brain. Okay? Someday somebody will say that, and we'll look back and laugh, and we'll do something else. But if you live like that, you're always buying the next computer every 3 months, and you won't be doing anything.
You just have to do the best you can with the resources that you have at the time that you have it, and be flexible and prepared to change.
Correct, but that's okay for when I'm looking at myself, right? But when I'm looking at someone else's career, when I'm mentoring someone else.
You tell them the same thing.
Yeah, it's very important to keep in mind that perfection is the enemy of productivity, and you see tons of brilliant people who are plagued by perfectionism. Remember, your paper is not going to solve the problem. It's going to be a building block in solving the problem. So you can analyze the data 20 different ways. You still need replication more than ever. So, keep that in mind. Let's not allow the perfection to get in the way of the good, really.
Some of my best and most highly cited papers, like in Science and New England Journal, would never be published today. Never. 16 subjects or 8 subjects in a science paper. I mean, come on. It never happened. And that's just the way it is. You do the best you can with what you've got and be prepared to move on and tell your grad student the same thing, and they'll know that too. And you have to be resourceful and really, really ready to change quickly.
In the mentees and graduate domain, try to be really careful about not publishing fabricated data. You have to watch what's going on, and the more senior you get, the more easy it is to get sucked into the graph and not be looking at the noise. So, I mean, from a mentorship perspective, that's probably the most important thing you can instill on your students as well, is plagiarism and fabrication and wishful thinking. Right?
It's extremely rare, really, but when it does happen, it's pretty shocking. It's never happened to, fortunately.
Nor has it happened to me, but it's happened to us at UCLA, and it's been bad. Okay, I want to bring this to an end, even though we're all having fun, and because we're going to have more fun. And Susan, who's our first debate group, and how are we going to do that?
Okay, I will set it up. Thank you.